This is our Siggraph show, and Siggraph is about innovation and technology. Siggraph has a long history of groundbreaking discoveries and insights into the potential future of our industry. Every year during the conference, hundreds of papers, courses, lectures, panels, installations, artworks, and experiences that could possibly shape the industry are shared. In that spirit, I'd love to give you a sneak peek into Maxon's own explorations into the future and the not-so-distant future. Today, we'll show you some amazing things coming from Red Giant, preview some exciting developments happening on Redshift, and finally give you some sneak peeks into the short and long-term future of Cinema 4D. First, we are excited to let you know that the Red Giant team is working hard on two major updates to Magic Bullet and Trapcode. These will be coming later this year. Magic Bullet will continue to push the boundaries of professional color workflows and introduce innovative new technology. As always, we expect you'll be amazed to see what the team has in store for Trapcode. Coming soon will be the latest update to Universe, our set of video transition and effects plugins for editors and motion graphics artists. It'll include 2 new tools and major updates to 4 existing tools that I'd love to have Harry Frank show you right now. Harry?
Thanks a lot, Dave. So in Universe 3.3, we have 2 brand new products and we have 4 major updates to existing products. So let me jump in and show you those right now. First, I'd like to show you Quantum. Quantum is a glow effect that renders projecting or converging light rays. It uses 3 different glows that you can enable or disable, and they are all independently color mapped. Next, we have Modes. Modes is a blend mode utility. You can select 2 layers to blend together and select different blend modes, up to 2 that you can mix and match together. For additional custom control, you can set this to a custom blend, and in the custom blend settings here, you'll find that you can do your own custom blend mode math. Glow has gotten a pretty big overhaul. Old Glow had a very soft, linear Gaussian falloff. The new version of Glow uses a much more refined technique where we have an exponential or inverse square falloff, and this is much more responsive to details in motion graphics. Chromatic aberration is an effect that simulates a lens blurring and color splitting around the edges. One of the things that we've improved with the new version of chromatic aberration is that instead of having 3 finite passes between the channels, red, green, and blue, you now have an arbitrary number of passes to really smooth out the process. So if I turn up the number of passes here, we'll get a much smoother rendering process with chromatic aberration. There's also a new center control to adjust the focal point of the lens. Universe Glimmer, which simulates a sort of star filter on the lens kind of effect, has gotten a pretty big overhaul. We've increased the number of glow streaks from 3 to 6, and now they can be monodirectional as well as bidirectional, so they can render in one direction or both directions at the same time. Lastly, we've got Hacker Text. What we've added in this version is the ability to animate the text on, so it can animate on and animate off. And it's doing all of this automatically. There's an automatic timing section in here, and all I need to do is define things like the direction that it's using, as well as the random characters that are used, which are also now custom definable. So before we just had upper, lower, and some random symbols. Now you can specifically define what you'd like your random characters to be. So that is everything we're working on for Universe 3.3. My name is Harry Frank, and thanks for watching.
Thanks, Harry. That looks great. We'll be releasing this in a couple weeks, and you can come and get your hands on it. Let's talk about Redshift. Redshift 3 has been available for a while now to licensed customers. Redshift 3 uses NVIDIA's OptiX 7 ray tracing acceleration and NVLink memory for both geometry and textures. Other features of Redshift 3 include general performance improvements of up to 30% or more, automatic sampling, which means you no longer have to manually tweak sampling settings, Maxon shader noises for all supported 3D apps, Hydra Solera support, deeper traces, and nested shader blending for even more visually compelling shaders. In the next few weeks, Redshift will be introducing OSL support, and soon thereafter, initial Blender support. Redshift 3 will then become the stable branch, and will be available in demo form as well. A while ago, we started talking about Redshift on Metal, and today we're extremely excited to show you the first version of this. We'll be bringing this out to public beta soon, and it'll be available to registered users on the Redshift forums. It'll be aligned with the Big Sur public beta. Here you can see us in Cinema 4D, moving around in one of the Redshift scenes, and you can see it's quite responsive on an iMac Pro. Here we are in the Redshift benchmark scene. It's showing how you can have very complex scenes with lots of materials, and it's still very responsive. And here you can see the USD Attic scene using OpenColor.io and the ACES workflow. I have sped this up so we can see the entire render. Please go to the Redshift forums, and there'll be sign-up information there in the coming days. Now I'd like to introduce Nicholas Burtnick from Redshift, and he's going to show you something very exciting.
Thanks, Dave. I'm happy to be able to give you all today a sneak peek of Redshift RT. This is a new render technology designed to complement the Redshift you know today. Redshift RT is a hybrid rasterizer ray tracer that aims to maintain the same workflows and host application integrations you have with Redshift, but with real-time or near-time performance. Before I start the demo, I should mention that we're still actively developing Redshift RT, and it will go through a number of optimization passes, and so we expect the production release to perform even better than what you see today. All right, so let me switch over to Maya. And here we have the attic scene that you're all familiar with now. We specifically chose this scene because it's a difficult scene to render. It's an interior scene lit from the outside, and it relies heavily on GI to fill the room with light. Right now, I'm navigating the scene with standard Redshift in IPR mode. Performance is decent, but it does take a few seconds to clean the frame to the point where you can start making decisions about the look. And for the record here, we're running this demo on a Razer laptop with a 2080 mobile GPU. All right, now let's switch over to Redshift RT. Right away, you can see it's way more interactive. And more importantly, you get pretty clean results almost instantly. I can tweak material and light settings and immediately see the results with full, accurate GI. Now notice we're working with real Redshift materials and lights, the same ones that you would use with standard Redshift. Notice that all the light shadows, secondary bounces, GI, and reflections are fully ray traced. This isn't using game engine hacks. Now don't get me wrong, those hacks are great and very clever, but they do generally involve giving up some degree of quality or flexibility. So that's all we're going to show for now, but the take-home message with Redshift RT is keep your tools, workflows, and pipelines and get close to real-time performance. Back to you, Dave.
Thanks, Nick. So as you can see, there's some exciting stuff in the future for our Redshift users, and especially our Redshift users on the Mac. When I joined Maxon 2 years ago, I discovered Maxon's philosophy was to keep things close to the vest when it comes to product roadmaps. But I don't always feel this is the best way to serve our community. Advances in technology are the single most important drivers of change in the business environment. I believe keeping you informed about changes that may affect the way you work and do your business is our responsibility. And having a subscription model gives us the freedom to be more transparent. While we won't talk about every feature we're working on, we are going to strive to be more open about the technology changes that we're going to allow you to do your job better. My first few keynotes with Maxon have been focused on our business initiatives, the acquisition of Redshift, our merger with Red Giant, and Cinema 4D releases. However, today we're at Siggraph, and I'd like to focus on our technology changes. So we're going to talk today about some exciting new stuff that's coming to Cinema 4D. The use cases, and to some extent the usability of these technologies, when first introduced, will not always be complete. But we're on a mission to do continual iteration, which is greatly supported by the subscription model. We want to make sure we will work with our customers to get the product correct for your workflow. So first off, we're extremely excited to announce that we're updating the Python engine to Python 3, which is the standard for motion graphics workflows in the 3D industry. Modernizing C4D's Python engine ensures that developers and pipeline architects have a robust and secure foundation for extending and customizing Cinema 4D. The great news is that the Cinema 4D API is still incredibly consistent, and developers should be able to adapt their existing tools with a very little minimal effort. You can read more about this in Rick Barrett's blog, just posted today on the Maxon website. To integrate with Cinema 4D, we offer the Cineware technology. This is the best way to integrate Cinema 4D into all of your workflows. It's already natively supported with Adobe, with After Effects and Illustrator. It's supported with Epic and Unity. It's also supported with Vectorworks and other architectural tools. However, we always want to support the most latest technologies in the way people interact. USD is making headway in helping to make it easier for 3D apps to work together. While all the partners we work with do support Cineware, we also want to make sure that we are compatible in future professional pipelines as well. So the next version of Cinema 4D will include the ability to import and export models, cameras, and lights in USD, USD-A, USD-C, as well as export into USD-Z. Here you can see us importing the famous kitchen scene from USD directly into Cinema 4D. And here you can see we're going to export the refrigerator out as USD-Z and open that on my iOS device and interact with it. You can see that working with Cinema 4D makes it extremely easy to support your AR workflows for Adobe and Apple products. While we're talking about Apple, this year at WWDC, Apple announced its objective to transition away from Intel-based Macs to Apple Silicon. I'm sure those of you in our Mac-based community are wondering about Maxon's plan to support this move. Cinema 4D has a well-known history of firsts on the Mac platform. Cinema 4D was the first professional 3D package to offer multiprocessing capabilities on a Mac, the first released as a universal binary for Apple's Intel-powered Macs, the first to support the 64-bit architecture of a Mac, and many other firsts. I'm happy to tell you that we will continue this tradition. Earlier this month, our development team already demonstrated for me a version of Cinema 4D running natively on Apple Silicon. So as Apple makes this transition, I can confidently tell you Maxon will be able to support our Mac artists wishing to take advantage of this new hardware, as well as those currently on Intel-based Macs. Next, I'm extremely excited to talk about something we've been working on for quite a while, and that is Project Neutron. We're very excited to preview the future of Cinema 4D. You'll see the beginning of this in the next release, and you'll be able to play with it and learn how it works and give us valuable feedback. And over the following releases, there'll be advancements that'll bring this to the core of how Cinema 4D works. Now, you've probably heard us talking about our efforts to develop a new core for Cinema 4D. We've been building a new engine under the hood for a while. Some examples of the steps along the way include a new core architecture, building a powerful and flexible threaded node-based foundation, and introducing node-based materials gave us an opportunity to exercise the power of that foundation and develop the user experience concepts needed for nodes. There have been many changes to the modeling core over the last few versions, which allow us to handle meshes in a more modern way. And most recently, we introduced the new viewport core, removing legacy connections and setting the stage for outstanding performance on the latest hardware technology. So I'm extremely excited to introduce Rick Barrett, one of the product managers on Cinema 4D, to give you a demonstration of Project Neutron. Rick?
Thanks, Dave. And hey, everyone. I'm thrilled to give you a first look at Cinema 4D's new node-based core. Nodes offers extreme performance, outstanding flexibility, and a clear view of dependencies. But our goal is to enable node-based workflows, not enforce them. So we'll be offering a GUI that offers all of the ease of use and ease of experimentation that Cinema 4D users love. That'll come soon, but let's take a peek at what's already possible today. So we'll start by simply creating a sphere. Here in the asset list, I'm going to search for sphere, and we'll just drag that primitive op right onto the scene, and you'll see that the sphere appears immediately in our view. Down here in the Attribute Manager, we have all of the properties we're used to. So let's go ahead and reduce the radius of this sphere. And let's do something that Cinema 4D users do all the time. Let's create a lot of copies. So I'm going to go over here to the asset list and search for grid. And we'll find the distribution op. This is very similar to the functionality you're used to from the cloner. It allows us to create a lot of copies of things in a certain shape. And we'll just drag from the output here onto the sphere, and you can see that we get a full grid of spheres. Down here in the Attribute Manager, we can adjust the properties and increase the count, and you can see we get great performance. We also have the option to choose between the various distribution types, and you'll notice a few new ones here. In fact, this system allows advanced users to build their own distribution types and share them with other users so this system can continue to grow. I'm going to choose one of my favorite new distributions, the spiral, and this allows us to create really cool Fibonacci spirals. If I build in a few more parameters to this, we can create a really cool animation. Here we're going to feed the time into the properties of the spiral, and we're also feeding and controlling the properties of a bend effector. Effectors in this system actually do double duty. They can affect the distributions, the clones, or the mesh, and you can see that we're getting great performance with a really cool motion graphics effect. This, in fact, is just our compatibility viewport. Let's switch to another scene, and I'm going to show you our high performance viewport that eliminates some of the shading possibilities but gives you the full power of the node system. And here you can see these fish swimming along smoothly, and they're pointing in the direction. This is all random movement. And in fact, if we want to see how this effect is built up, we can dive right into this group, and you can see all of the nitty-gritty nodes that make up this effect. Let's take a look at another scene that shows the procedurality of this new system. Here we have a tree, and in fact here you see that we're only seeing a node for the forest. And we can go in here and adjust the seed, and you can see that we can create all sorts of procedural trees. Well, if we increase the count of trees, you can see that we're actually able to generate an entire forest of random procedurally generated trees, and we have great viewport performance as we navigate around this forest. And just as before, we can dive right in and we can take a closer look at how the forest is built, dive in further and take a look at how the trees are built. And the great thing is that these groups can be packaged up as assets and shared with other users so that everyone can take advantage of the functionality. One more scene I'm going to show you, and that is some of the procedural geometry manipulation that we've built into the system. And we were able to add this in easily because of the work that's already been done on building a new modeling core. So here you can see that we've taken this elephant and we've extruded some of its polygons and created a really cool scaling effect. Let's grab the fish from earlier in the demo and use it instead. And I'm going to turn on a dual mesh option, which does a little bit more manipulation and creates some really cool scale type effects. We can go ahead and adjust the inset, the variations, we can tweak the offset, and get a lot of different effects here just by changing the publish controls. So that's a quick overview of our progress on Cinema 4D's new core. This is just the beginning, and I'm having a ton of fun playing with it. I'm sure you will as well as soon as you get your hands on it, and we're really looking forward to your feedback as we build the future of Cinema 4D together. Back to you, Dave.
Thanks, Rick. It's important to note that this is not just nodes. While the foundation of this system is nodes, our goal here is to enable a nodal workflow, not enforce one. We know that Cinema 4D users value its fast, intuitive workflow that enables and encourages creative exploration. We'll be creating a workflow very similar to, but even better than the current Cinema 4D Object Manager, which creates nodes in the background. Users will always have the choice to design intuitively, interactively, and experimentally, and to easily view and construct a complete roadmap of dependencies that comprise the scene.